Hello students, today we're going to be looking at scatterplots. These are part of our chapter 9, section 9. A scatterplot, you'll see that as either two words or one word. It doesn't really matter how it's shown. Some books are one, some are two. Is a type of graph that plots data points to show a relationship between the variables. So it'll show x, y ordered pairs on a graph. So it's comparing your x's and y's and looking at that relationship between those data points. So the scatterplot is just the graph with dots. A line of best fit is sometimes called a line of fit. It's the estimated linear equation, so usually it's given in slope-intercept form that goes through the middle of the data. So it, sometimes when you draw it, you'll have the same number of dots above and below. It doesn't have to be the same number, but just so it roughly goes through the middle of that data. Correlation describes the relationship between those x and y values, and there's three ways to describe correlation. Correlation is described as positive correlation. That's when both of the values are going up, increasing from left to right. So if we look at this first example, this is a positive correlation. These dots are kind of clustered in a fashion that goes up. It's like a positive slope. So if I were to draw the line of fit, it would look something like that. So that's a positive correlation. The data is going up like a positive slope. In the second example, you can see the cluster of dots is going down to the right, just like a negative slope. So we would draw a line of fit kind of like that. So it looks like it has a negative slope. So positive correlation, the cluster of dots is going up to the right. Negative correlation, the cluster of dots is going down to the right. In the last example here, there's no correlation, or we would say the correlation is none. There's no relationship between how these dots are put on in the x and y fashion. So the dots are just kind of scattered all over the place. There's no real pattern. So we would just say that that has no correlation, or there's none for the correlation. Okay? In the next set of examples, or in the example, graph the data points that was given to you by your teacher. There should be some data points from the STAR reading test, or the STAR math test, showing the percentile rank for the Y and the time that students spent taking the STAR math test. So the percentile rank and the time. So take a few minutes now, pause the video, put those data points on the graph that was given to you. Okay, so now that you have the data points on, they should look something like this, where all these blue dots are. Those are the ordered pairs of those data points. Notice they kind of form a positive correlation. So we talked about the correlation here. So this looks like it has a positive correlation because this cluster of dots is going up to the right. Next, I'm going to show you how to draw a line of fit. So I'm going to take my line over here, and we'll put that line. So it's going through the center of that data. Since the line of fit is an estimate, there's not an exact answer here, but as long as you're in the ballpark and your line is somewhere close, that should be fine. Now we're going to look at writing that equation line to go along with that line of fit. Remember, the equation we use is typically given in slope-intercept form. So we're going to be looking for y equals mx plus b. The b value is where it crosses that y-axis. Now this graph counts by tens. So going down, it looks like this line of fit line that we drew looks like it crosses at -10. So that'll be our b value. So we have y equals something x minus 10, or we could say plus a -10. So what we need to find is we need to find out what is the slope of this line. So to find the slope of this line, we need to find the rise and the run. So what we're going to do is find some ordered pairs that are on this graph and just estimate the rise and run. So if we go here, it looks like it goes through down here at about the 5:10, and then it looks like it crosses again at 15:40. So if we just count that rise and run, it looks like it rises 10, 20, 30, and then the run, since the run, it counts by 5, so it looks like it runs 5, looks like it runs about 10. Let's see if it follows that same pattern anywhere else in the graph. So maybe we look at these two ordered pairs, and we can look at the rise and the run. So if we look at the rise on this part of the graph, again, it looks like it rises 30, 10, 20, 30, and then it looks like it runs another 10. So it looks like the rise and run of this graph, rise looks like 30, and run looks to be about 10. And of course we can simplify this. So we'll say the equation is y equals 3x minus 10. So when we look at this equation, again, it looks like a positive slope. It's going up to the right. This would be an approximate line of fit. Y equals 3x minus 10. So that's just writing an equation to fit with those data points. We can use this line of fit to make estimations. So if you had, a student who spent about 20 minutes on the test, you could approximate what their percentile rank would be. So if they were 20 minutes testing, you could follow that line vertical, hit your line of best fit, and then look horizontally. You could estimate that a student who spent 20 minutes on the test would have a percentile rank of about 50. Okay, so this can help make predictions based on your data. So not just the data points, but you can also use that line of fit to make predictions based off of the data as a whole. Thank you. Have a good day.